Hello, everybody. I hope everyone is having an amazing morning. Thank you for joining me for my talk on decoding Perplexing TypeScript. My name is Daria Caraway. I am a senior software engineer at Netflix, where I get to build React and TypeScript applications for the teams that schedule all of our content across the world. And I'm based out of Colorado in the United States, and I've been an avid lover of TypeScript for almost a decade now. Now, there are so many reasons why I love TypeScript, but oftentimes complex code that supports lots of different use cases can lead to really complex types. And I'm sure that a lot of you who said you use TypeScript have been in a situation similar to this, where you see a type and you need to know what's going on, but that type is composed of lots of other types, right? So you click into one of those subtypes, takes you to a new file, you've never seen it before. That type is composed of all of these other types. You click on one of those, it takes you to another file. That type is composed of all of these other types. And it can start to feel like you're trapped in this never-ending labyrinth of TypeScript code. Well, today we're going to play a game based off of that feeling. Trapped inside of a labyrinth, we are going to have to decode types at every level in order to escape. And I'm going to be really honest with you all. The final boss, level 4, it's pretty confusing. There's a lot going on. It's really hard to decipher based off a first look, but I promise you that we are going to be able to decode this type by the end of the talk. And along the way, we're going to be able to use things out of our player inventory. These are TypeScript skills and tools that we're going to pick up through all of the levels that are going to help us ultimately decode the final boss type. Much like starting out with TypeScript just in life, we're going to start out with primitive types like strings and numbers and booleans. But as we go, we're going to start to fill out our player inventory and start to pick up some more complex types. Because I think a lot of the times with TypeScript, one of the hardest parts is just knowing what all of the types are called. Because once you know what they're called, you can look them up, you can find examples, you can isolate them. So my goal for today is that everyone here puts at least one more thing in their own TypeScript player inventory that will help them throughout in the world. And like I said, the levels are going to get more complex, but I truly believe that breaking down TypeScript types does get easier the more tools we have in our inventory and the more practice we have using them. So with that, I want to enter the labyrinth together. We will all be player 1, starting with level 1. Now we have a type for level 1. It's not huge. It's not the most intimidating type you've ever seen. It's a type called isTruthy. But even in this type, we already need to have several things in our player inventory in order to properly decode it. We have things like generics and unions and conditionals. So first, we're going to break down these types, right? I'm just going to spread them out. I'm going to give us some room to work with. Then we're going to jump into all of the parts. The first thing in this type that I think is really important is that it contains a union type. And union types are extremely fundamental in TypeScript for putting lots of different types together. So here, a union type represents a type value that can be one of many things. This one, for example, can be null, or undefined, or false, or 0, or empty string. So putting that back into our type, I'm going to start to make these types read more like English sentences. This is not valid TypeScript, but we now know that our union type is null or undefined or false or 0 or empty string. The next thing we need to dig into is generics. And generics are everywhere. They're a super fundamental type in TypeScript that allows you to make your types responsive to any sort of different input types. And they make components and APIs more generic. So basically, a generic is a stand-in representation for a type that will either be provided as input or potentially inferred by TypeScript. But in this example, type T represents a type that is going to be passed in by the consumer. So my favorite way to break down TypeScript types is just to take really isolated examples, put them into my IDE, and just start throwing examples at it. I want to try to reverse engineer these types and have my IDE tell me what TypeScript is resolving these types to. So we have an isolated example here of a generic type. It takes a generic type T, and it's going to give us back a type that is a union of T or an array of T. And if we put this into our IDE and start to throw some examples at it, we can see that if we pass in a string, we get back a type that resolves to string unioned with string array. So you can start to see that whatever we pass in, TypeScript is going to drop in for those t's. So now putting that back into our type, I've renamed the generic type passed in, because that's what's going on here. Our type is Truthy is going to take a type being passed in. And something important to note with generics is that they're often notated with a single letter, like a T or a K or a V are all very common, but they don't have to be. You can name them whatever you want. So we're going to call ours today type passed in to make it clear what's happening. The last piece we need to fully break down this type is to know about TypeScript conditionals. So much like JavaScript conditionals, TypeScript conditionals allow you to do an if-then assignment based off of some sort of generic statement. So in this example, if type passed in extends null or undefined or false or 0 or empty string, then the value that TypeScript is going to resolve back to us is false. Otherwise, the type is going to resolve to true. So all together, if we take an example of our fully built out decoded type, we have type is Truthy. If we were to pass in something like null, what would happen? Well, if null extends null or undefined or false or 0 or empty string, which it does, null extends null, then the value that TypeScript is going to resolve to is false. But if we were to pass in a generic type like a string, string doesn't extend null or undefined or false or 0 or empty string, so we're going to get back true. And now what we have is a pretty simple type that tells us based off of an input type whether or not that type is truthy or not, which can have a variety of use cases. Okay, so level 1, we're checking back into our player inventory, and we've already picked up all of these new tools. We've collected our trophy, that's important. We've got our 3 new type stars, which brings us in to level 2. Okay, we all kind of see what's going on here now, right? We're gonna go through these levels, we're gonna decode these TypeScript types, we're gonna pick up all of these tools, and by the time we get to level 4, I promise you, it will mostly make sense. On to level 2. We have a type here called Omit, which, if you're familiar with TypeScript, this may be familiar to you, but there's already so much going on here. I think we've stepped it up a level, right? There's lots of words and letters and brackets and subtypes, but we already know about our generics, so I'm going to spread out our type, give us some space to work with. We have our type passed in, and then we have a second generic here called K. And K has other things going on with it, so I don't want to name it yet until we dive in to figure out what's going on. So let's do that. Here we have a key of operator. So key of gives you a union of all of the keys of the type that you've passed in. So if we take an example object type, A string, B number, C string array, if we were to call key of on this type, we would get back a string literal union of all of the keys, A, B, and C. Pretty straightforward. Paired with an extends, we're saying that K must be a subset of all of the keys of type passed in, otherwise the extension will not pass. So now we know that the second generic getting passed into this type has to be some subset of the keys of the type passed in. So we have omit, it takes a type that gets passed in, and we have some keys that we're also going to pass in. Let's dig into the next pieces. Here we have a couple of utility types. Utility types represent common type transformations that are globally available and provided to you by TypeScript. So let's take a look at the inner utility first. The inner utility is an excludes type. Exclude, you give it a union of something, and then you tell it things in that union that you want to remove or exclude, and it will give you back a type with those things removed from it. So we've taken our keys from our example object type, we have the union A, B, and C, and now we're going to exclude B as an example. That's going to give us back a new type, which is just the union of A and C. So you can see, we got all the keys, we excluded B. Now we're going to take the output of that and pass it into pick. Pick is another utility type that returns you a type with only the properties on that type object that you've told it to keep or pick. So we got all of our keys, A, B, C. We excluded B. That gave us just A and C. Now we are going to pick off A and C of our example object type, which is going to give us back a new object type with just the properties A, string, and C, string array. So we've successfully removed the property B. Altogether, we took all the keys. We excluded the key being passed in, which was B. We picked off the remaining ones, and that gave us back a new object with just A string and C string array. And that's the exact behavior of omit. And if omit looks familiar to you because you're an avid TypeScript user, it's because omit in itself is also a utility type. So we've now just created a utility type with two other utility types, but omit hasn't always been a utility type. So it's possible if you work in older code bases, you may have seen it declared, but you don't have to declare it anymore yourself. You can just use it. So in just level 2, we've now picked up 3 utility types into our player inventory, and these are going to help us as we move forward. Okay, we got our trophy, we got our 3 type stars, everything is looking good as we head into level 3. Okay, level 3. It's not the biggest. In fact, it might be the smallest type, but I think it's complex for a different reason. But we have generics, we have our conditionals. Go ahead and spread that out, rename our generic type passed in. We're going to spread out the conditional statement. There's something else going on here, because we have another letter, U. And U looks like a generic, right? But it's not being passed in. So something else is happening. And this is the reason why I think level 3 is a little bit more complex. Because even if you're an avid user of TypeScript, you may not have seen this in your day-to-day. It's a little bit less common. But if you need it, it's really helpful. This is type inference. So if you've used TypeScript, you've likely used type inference whether you know it or not. It's like when you declare a constant, but you don't tell TypeScript exactly what type that constant is. TypeScript is going to take all of the context that it has throughout your entire code base, and it's going to infer a type that it knows it can uphold 100% of the time. And if it can't uphold it 100% of the time, it will either give you an error or type it as any, depending on your TypeScript settings. That's a whole other debate. But a similar thing is going to happen here. So TypeScript is going to try to match the type passed in to this A, B object structure. And based off of the context of that type passed in, it's going to try to infer a type for you. And I'll show you what I mean. Say we have an example type, A string, B string. If we ask TypeScript to try to match it to this A-B structure, it will successfully be able to do so. And because it knows that you're trying to match a type for you, it will be able to infer you as a string, because the structure matches, both the types are the same. It makes sense that in this case, it can 100% tell you that you is going to be a string for this type. So now we have if the type passed in extends our AB object structure and TypeScript can successfully infer a type, then the type value that gets resolved is going to be the inferred type itself. Otherwise, we're going to resolve the type to never, which is basically us telling TypeScript that's never going to happen. That's an impossible case. So if we were to pass in a type like string to our valid double object type, well, string doesn't extend this AB object structure, right? TypeScript can't infer a type for you. It doesn't match at all. There's no way it can tell us what you is. So we're going to get back never. But if we were to pass in a type like A string, B string, that successfully matches. It's very clear. TypeScript can infer the type to be a string. So we get back string. Checking back in, we picked up our type under type manipulation, inference. We got our trophy, and we only got 1 star this time. But you know what? It's okay. It's an important star. It's a unique star. Which takes us to level 4, which I've already showed you is terrifying. So let's all just take a breath. That was for me, but also for everyone here. And let's dive in. Okay, this type is scary. We already know that. It has almost all of the types we've already talked about, and more, somehow. There's still more somehow. And maybe normally we would see this type, and we would just like rage quit the game, close the file, pretend like we don't need to know what's going on, right? It's one of those where like the code's working. We don't really need to know what's happening here. Let's just kind of like forget that we saw it. But we don't have to today because we've already collected so many tools in our toolbox. We're just going to spread it out, fill in what we already know. We have our type passed in generic. We have an excludes. We know that exclude is going to remove something from a union. We have the extension on our AB object type with type inference. We have our isTruthy type, which was a whole example from level 1, right? We're going to use that in here as well to check if the inferred type is truthy. We have conditionals. We have key of operators. It's got everything. There's a couple more things that we still need to break down. There's a lot of brackets happening here. What are they? Well, this type is really cool because it's actually a mapped type. So a map type, just like mapping over an object or an array in JavaScript, gives you back a new type with all of the things in your iterator mapped to a new type value. So in this example, we're going to map all of the keys in our type passed in. We're going to iterate over them and map them to some other type value that we specify. So just as a really basic, isolated example, let's take all of the keys from our type passed in and let's map them to true, just to see how this works. If we take our example object type, A string, B number, C string array, we're going to loop through all of the keys, A, B, C. We're just going to map them to true. So should look familiar, right? Just like mapping over a JavaScript object, we've changed all of the property value types to be true. And just like mapping over an object type, K is an iterator of our things that we're looping over. So in this example, K is an iterator of all the keys, which means that we can use K to index back into the object type to give us back a property value. So we take our example, and on the first iteration, K is going to be A, because that's the first key. We can now use A to index back into our example object type, and that's going to give us back the type of that property, right? Okay, all looks familiar. All looks like just JavaScript, but again, all of this runs in the type checker. There's no JavaScript running here. And that's great, but there's something else happening in this type. And I would venture to bet that most of the people who raised their hand that said they use TypeScript have maybe never seen this, because it's a bit peculiar, and there are other ways to accomplish this that maybe you've seen, but it's really, really handy if you need it. This is a mapped type modifier. Now, there are a handful of these modifiers that you can apply to types as you map over them, but this one is going to remove the question mark or the optionality from our properties as we iterate over them. So we know if we have a new example object type with A string, B number, but this time A is optional. It has the question mark. We're telling it that it's allowed to be undefined. We can pass in undefined and TypeScript won't give us any sort of error. If we go and map this to true, like we did before, with our map type modifier, A is going to get its optionality stripped off. It's going to be made required. So now A no longer has the question mark, and both A and B have been mapped to true. So something really handy that's not super common, but kind of neat. Sorry, Tejas was taking a picture of my super cool slide. I'll give it. All right, so we now have all of the tools that we need to decode this type. We have our key iterator, so for each key of type passed in, we're going to make it required. We have the indexing, so we're going to exclude null from the value of our current iteration, which brings us to an example that we can run through. We have an example type. It has one property on it called valid1. Valid1 has a type of A string, B string, unioned with null, so very similar to what we've seen before. We know that we're going to iterate through every key of our new type, which only has one. So we know that we're going to get a result type of valid1 mapped to something that's going on in the rest of this wild type. First, we're going to exclude null from the value property of this key. So we're going to have A string, B string, and remember, exclude strips off what we tell it to from a union. So we're going to exclude null from this union, which is going to give us back just the type A string, B string. We're then going to ask TypeScript if our A string, B string extends the A, B object structure, and if it can infer a type, which we know it can. We know it will infer the type to be string. Then we're going to check if that inferred type is truthy. And we know that string is truthy because it doesn't extend null or undefined or false or empty string or 0. So the value that we map to is going to be a string of the key itself. So we now have a result type with valid1 mapped to the string valid1. Last, we're going to index back into this object and pull out all of the values, which is going to give us back all of the valid keys, which in this example is just the key valid1. Okay, we did it. We ran through it. It all made sense, right? Well, what happens? Okay, so we have our example that just had the one key. We got back valid1. What happens if we put another property on this object that's invalid? This not valid string, that's not going to match our AB object structure. TypeScript's not going to be able to infer a type from that. So we're going to drop down into the last conditional statement, which means that in valid1, the key, it's going to get mapped to never, which is us telling TypeScript, this key, this property, it's never there. As far as TypeScript is concerned, this property doesn't exist. It never exists. Which means when we go to get all of the property values back off of this object, we're only going to get back the keys that were valid and weren't never, which again is just the example of valid1. Altogether, it's kind of a powerful type, right? You can throw in all sorts of properties on here, and we can pull off just the names of the keys that we know are valid types. So imagine you're a component author or an API author, and it has to fit a wide variety of use cases, right? You want to allow consumers to pass in some things. Maybe some of them just get passed along, but we want to only do something to the keys and properties of this type that were valid. Now we can know which ones are valid just at the type layer and tell the consumer and give them this information. Okay, I have another example that I think is really cool because when I was going through this for the talk, I was throwing in lots of examples that I think would be interesting, and this one threw me a little bit for a loop because as far as we're concerned, we already know that the A string, B string object, we've seen it 100 times now, we know that this is a valid type according to our validator. But if we run this example type through our valid keys, it's going to tell us that it's never, which is peculiar because we just saw that the other one was valid. Which means that there's something about this type being optional that is making this resolve to an invalid key. Why, right? Let's dig into it. First thing, whenever I don't know what's going on with TypeScript, which again happens to everyone, I want to make sure that what I think is going on is what TypeScript thinks is going on, right? So first thing, I'm just going to put in the example that we're working with into my IDE. Oops. And I'm going to hover over it just to see, just to level set with TypeScript, make sure we're all working off of the same type here. But you can see that under the hood, TypeScript is actually exploding out this optionality. It's saying that in valid1, it can be the AB string object, unioned with undefined, which again, the question mark is just a shorthand for this, but it's not always obvious that this is what's going on under the hood. So as we go through our decoded type, I want to make sure that we're using the type that TypeScript is using so that everyone is on the same page. Now, let's iterate through all of the keys of this type passed in. We know there's just one, so invalid1 is going to get mapped to something. We're going to exclude null from the property value. There was no null here, so this is a bit of a no-op for this type. Then we're going to ask TypeScript if this type extends our AB object structure, which turns out it doesn't, which is, again, kind of interesting because we know A string, B string does extend our AB object structure. But what we're saying here is that sometimes the type will be A string, B string, but sometimes also it might be undefined. And in the cases when it's undefined, TypeScript can't match the object structure, it can't infer you a type, and because it can't guarantee 100% of the time that this statement is going to pass, it's going to fail. Which means our key invalid1 is going to get mapped to never. And when we go to get these keys off, they're invalid. We don't have any. So we have all of these different things that we can throw at this type, interesting use cases, And again, as I was building out this talk and decoding these types, I was just reverse engineering everything out of this type, giving it all sorts of edge cases that I could possibly think of. And now we have this really handy type that gives us back only the valid keys of our object property. Okay, we did it. I told you we could do it. I told you we would do it. I told you we would get the little trophy, the cute little trophy. We got our 4 new type stars. And we can finally see the exit of this labyrinth that has felt never-ending, even though it's only been 26 minutes, right? But in that 26 or so minutes, we've already unlocked so many types in our inventory. And this is not all of them. This is just kind of an introduction, right? And the TypeScript docs are so great for seeing all of the options. You can go in and learn about type manipulation. You can see all of the utility types and learn about them. You can see all of the different intricacies of object types. But my favorite way to learn about TypeScript is just to start taking types that I see out there in the wild, especially the ones that make no sense whatsoever. Just start individually breaking down all of the pieces, throw them into your IDE, throw them into a TypeScript sandbox that you can share with all of your friends and work on them together, and just start to reverse engineer the TypeScript type checker until you start to get a feel for, oh, if I make this optional, it's actually unioned with undefined, things like this. Thank you so much for coming on this journey with me, playing our game today. Again, my name is Daria. If you see me throughout the conference, please feel free to come up and say hello. I'd love to meet you. Thank you.